Alright, in this video we're going to do an example related to the formal definition of a limit. So, suppose we're given that the limit as x approaches 1 of 2x plus 3 equals 5. We want to find the largest value of delta so that epsilon will be less than 0.01. And graphically all this means is the following. So let's graph y equals 2x plus 3. So y equals 2x plus 3 is just a line with a y-intercept of 3 and then a slope of 2. So there's y equals 2x plus 3. And again, as x approaches 1, notice that the y values again would get closer and closer to the value of 5. What we want to do is we want to find some interval around the number 1. So we've got some interval, this new point on the right is going to be 1 plus delta, and the number on the left will be 1 minus delta. And what we want to happen is we want to be able to find x values within a certain interval around the number 1 so that we're within 0.01 of our limit. So here's the number 5. So let's see, here's 5.01. Okay, so there's 5.01. There's going to be some x-coordinate associated with that y value. And likewise, if we subtract away 0.01, that would give us 4.99. Okay, so again, what we're trying to do is we're trying to figure out what x-coordinates will give us a value that falls inside of this interval that'll give us y values between 4.99 and 5.01. Okay, so what I'm going to do, since this is a nice linear equation, is I'm just going to solve. So for the y value 5.01, I'm going to figure out what x-coordinate would give me that y value. So we can subtract 3 from both sides. Well, 5.01 minus 3 would just be 2.01 equals 2x. And if we divide by 2, well, let's see, I guess that would give us 1.005 equals x. Okay, so really this right endpoint, this x-coordinate, is going to be the x-coordinate 1.005. And we can do the same thing. We can figure out the x-coordinate that's smaller than 1 that gives us the y value of 4.99. So 4.99, that equals 2x plus 3. We could do the same thing, subtract 3 from both sides. That'll give us 1.99 equals 2x. And then if we divide both sides by 2, that's going to give us x equals 0.995. Okay, so this x-coordinate on the left is really going to be the x-coordinate 0.995. So let me draw maybe one more little picture here. What it really says is, okay, so there's 2x plus 3. So there's our value 1. It says if we're over here at 0.995 and over here at 1.005, it says if I take any x-coordinate inside of there, strictly inside of there, it says I'm going to get y values, so there's 5. It says we're going to get y values that are within 0.01 of that number. And basically now we're done. We've now found our delta in this case. Okay, so again, delta, so a little should fall straight down there. So delta again is the distance from your number 1 out to the endpoint. So notice in this case it's symmetric. If you go over 0.005 to the left or to the right, if you take any x-coordinate that's within 0.005 of the number 1, we're going to get y values that are within 0.01 of the number 5. So in this case, delta would simply equal 0.005. So again, one more time, because I think the definition of a limit is very, very confusing the first time you see it. It says if you take any number, so it says if you plug in 1, hey, you get the number 5. it says if you go at most 0.005 either to the left or to the right, okay, and we don't use the endpoints 0.995, 1.005. If you take anything in between those two numbers, though, it says you are going to get y values that are within this epsilon of 0.01. Okay.